This movie is for learning target number 6, unit number 3, parallel perpendicular lines. One application of parallel and perpendicular lines is when you're looking at a map. You have many parallel streets. Sometimes you have streets perpendicular to other streets, but it's a really great application of all the theorems we're going to be talking about in this section. Let's take this theorem. If two lines are parallel to the same line, you can see that line A parallel to B and line C parallel to B, they're going to be parallel to each other. And so let's add this theorem to our handbook, and then pause the movie, add it to your handbook, press play when you are finished. We have another theorem that we're going to add. It says in a plane, if two lines are perpendicular to the same line, then they're going to be parallel to each other. You can see that M is perpendicular to T, N is perpendicular to T. So because they are both perpendicular to the same line, as long as we're working in the same plane, they will be parallel to each other. Pause the movie, add that to your handbook, and press play when you are finished. Let's look at a proof for this. In a plane, R is perpendicular to T and S is perpendicular to T. Don't forget that symbol means perpendicular. And we want to prove lines parallel. So notice we are not given lines parallel. In line 1 we have given, because I can see it written right there. So we have that they're perpendicular. What allows me to say that angle 1 and angle 2 are right angles? Well, I've established that the lines are perpendicular. So this is definition of perpendicular lines. Because they're perpendicular, then I can say they're right angles. Now what allows me to say that angle 1 is congruent to angle 2? It's because all right angles are congruent. Now that I've established 1 and 2 are congruent, you can see that they're corresponding angles. So I can prove that lines are parallel by the converse of corresponding angles theorem. I've established that the corresponding angles are congruent, so by the converse I can say lines are parallel. And that's our proof. Carpentry. When we are planning to install molding on sides and the top of the doorway, the carpenter cuts the ends of the pieces so that each one pieces into a 45-degree angle here and here. When we put those together, we end up with a 90-degree angle here and a 90-degree angle here. Will the side pieces of the molding be parallel? Will these two sides be parallel? The answer is yes, since both sides are perpendicular to the same line, then the sides are parallel. Pause the movie, try this one on your own, and press play when you are finished. So you can see when you try to make a picture frame, and you've got these pieces, we can place it so that my 30-degree angle butts up against the 60. And we could do that all the way around, and that does form a 90-degree angle. So this one is also yes, based on the same information, that we've got two opposite sides are going to be parallel since they are both perpendicular to the same line. We have a perpendicular transversal theorem. It says in a plane, if a line is perpendicular to one of two parallel lines, so we've got this line's perpendicular to one of two parallel lines, then it's going to be perpendicular to the other as long as we are working in the same plane. Pause the movie, add that to your handbook, press play when you are finished. All right, down here it explains why it needs to be in the same plane. As you can see here, if we have one coming across like this, it can be perpendicular, but it's not going to be in the same plane, nor will it be parallel to this one. So just keep in mind it needs to be in the same plane. Pause the movie, try doing this proof on your own, and press play when you are finished. So yes, this is a paragraph proof. It says lines C and blank are both perpendicular to B. So lines C and D are both perpendicular to B. So C is parallel to D. Because two lines perpendicular to the same line are parallel. I'm going to put my symbols in there. It is given that blank. Therefore, C is perpendicular to A because a line that is blank to one of two parallel lines is also perpendicular to the other. So I use the fact that C and D are both perpendicular to B. So I've used these two already. I'm probably going to use the fact that D is perpendicular to A. It is given that D is perpendicular to A. Therefore, C is perpendicular to A if we extend it, because a line that is perpendicular to one of two parallel lines is also perpendicular to the other. What is the relationship between segments AB and CD? Pause the movie, try this on your own, and press play when you are finished. The relationship is that they are parallel. We've got that these two angles formed are 90-degree angles. So they are, in fact, perpendicular to the same line, so they are parallel. And we're going to skip this one, but I wanted to show you something real quick. When I was in England, came across this doorway where the door frame just seems so much at an angle. I was surprised the building was still standing. This is in Canterbury, England, an old bookstore in the town. And you can see that it hits this line up here, the door frame at the top, not at a 90-degree angle, but that doesn't mean the two sides aren't parallel. If we're looking at that door frame, and it's going like this, as long as these two angles are supplementary, then by the converse of the same side interior, these lines would be parallel. So it doesn't always have to happen that they hit at a 90-degree angle. Thanks for watching my